Hey everyone. So for today's lesson, yesterday we spent the day talking about the first algebraic way of solving systems, which was solving by substitution. For today's lesson, what we want to focus on is the other algebraic way, which is called elimination. Now the reason it's called elimination is because I set things up so that I eliminate one of the variables, and when I eliminate one of the variables, I can solve for the one that's left, okay? Now, before I show you all the steps of that, I don't want you to think that what we're doing is just some sort of magical thing, okay? I want you to understand a visual. So what we're gonna do first is I'm just gonna create a random, if you were actually in class with me, I would just get you to come up with the numbers. But I have just created a random system, and I'm going to put on a graphing program on my computer here, and I'm going to walk you through a couple of the visual aspects of the system, graphing the system, to help you understand what elimination is all about visually, okay? So let's take a look at a system together. Okay, so on the board behind me, I've written a random system, okay? I have a system of equations with two unknowns. I know they're both linear because I've got 2x plus 5y minus 10 equals 0. That's got an x and a y with no exponents, and 3x plus 4y plus 2 equals 0. I've got an x and a y with no exponents, okay? So I know I have a linear system. First thing I'm going to do is I want to graph the system, and that's something you've already done before. So we're going to take this guy and we're going to write it in terms of y equals. So if I took that guy and wrote it in terms of y equals, I'd have to bring my 2 over, I'd have to bring my negative 10 over, so that would be 5y equals negative 2x plus 10, and then I'd have to divide everything by 5, so I'd have y equals negative 2 over 5x plus 2. Okay, so now if I graph that guy, that one would look like this, negative 2 over 5x plus 2, okay? Now, this guy here, I'm going to do the same thing. I'm going to write it as y equals. So I'm going to keep my 4y there. I'm going to bring my 3x over and bring my 2 over. So that will be 4y equals negative 3x minus 2. And that's y equals negative 3 over 4x. When I divide everything by 4, 2 over 4 would reduce to 1/2, so that would be negative 1/2. And if I graph that guy, I would see this line here. Okay, so now I see the intersection point, okay? I know that whatever that is right there is the solution to my system, okay? Now, just for fun, and just to prove the point I wanted to prove with you, I'm going to add these two guys together, okay? If I was to just add those two together, I get 2x plus 3x, that's 5x, and 5y plus 4y is 9y, and then negative 10 plus 2 is negative 8, okay? Now, just for fun, let's graph that guy as well. So I want to write this in terms of y equals, so I'm going to go 9y equals negative 5x plus 8, divide everything by 9, y equals negative 5 over 9x plus 8 over 9. So now I'm going to go ahead and graph that. And here's what I want you to notice. When I go ahead and graph that, although it's a new line, the intersection point has not changed, okay? It's still hitting the same intersection point that my original 2 hit, okay? So when we have a system and we add those two equations together, it will create another equation that will still share that same intersection point. Well, what happens if we subtract? Now I'm going to play a game here, and I'm not doing this to frustrate you. I'm going to take these two y equals ones, and I'm going to subtract those guys. Now I know that that's going to have messy fractions for me. That's okay. We're going to do this together, and everything's going to be fine. So I'm going to go and subtract that for a sec. So I'll do that right in this space right here. So I'm going to subtract. So I need to go negative 3 over 4, subtract negative 2 over 5. Okay, do you see that? So I'm just going to do this on the board. Negative 3 over 4, subtract negative 2 over 5. So I need a common denominator. That would be 20. So this would end up being negative 15. And then this is actually adding, right? And so that would be plus 8. And so that would be negative 7 over 20. So this would be negative 7 over 20x. Okay, and then y minus y is 0. I've got negative 1/2 minus 2. So that would be negative 2.5. Negative 2.5 would be negative 5 over 2. So that would be negative 5 over 2. I'm going to add 5 over 2 to both sides. Okay, I want to get x all by itself here. So now I'm going to say, hey, this is the same as if I wanted to make that over 20, that'd be 50 over 20. Okay, and so now I've got 50 equals negative 7x. So x is negative 50 over 7. Okay, negative 50 over 7. Now watch what happens when I graph negative 50 over 7. Okay, so negative 50 over 7. And take a look at that. Okay, do you see, again, that follows the same intersection. So now a couple of things have happened here, and I'm trying not to get too excited because I want to make sure you understand what's happening. First of all, two things. When you add a system together to get a new equation, or when you subtract the system to get a new equation, it doesn't change where the intersection point is. Okay, but even more than that, this is the value for x in my system. Yes, I got an equation of a vertical line here, but that also tells me the value of x for the system. And so actually what I did right here, even though it was kind of messy and with fractions, what I did right here was I said, okay, I'm going to figure out the value of x by eliminating the value of y, because I knew when I not the value of y, but eliminating y, okay? Because when I subtracted these equations, my y's would disappear. And allowing my y's to disappear, knowing it doesn't change where the intersection point is, allowed me to figure out the value for x, okay? So I want to make sure you have a visual of what elimination is all about, so that as we go through elimination, I don't want you to think that it's just magic, okay? So what happens to the solution to the system when we add in an equation that is added or subtracted from the two original equations? The solution stays the same, okay? And that is super, super helpful when we go to try and think about how we're going to solve the system by elimination. So the steps. Number one, make sure that the equations are simplified and in the same form. Now, what I mean by in the same form is we need to have x's on top of x's and y's on top of y's and numbers on top of numbers, okay? Number two, make the coefficients of one of the variables the same number. So you can either have the same sign or opposite sign, it doesn't matter. So we could have 3x and 3x, or we could have 3x and negative 3x. Both of those are perfectly fine, okay? To do this, multiply the entire equation, both sides, remember, always every term on the left side and every term on the right side, by the same number. Then you're going to add or subtract the equations to eliminate the variable and solve for the variable. Once you've got that variable, you'll substitute back into one of the original equations and solve for the second variable. Okay, so I know it doesn't really make sense when we're just reading it, so let's work on a few examples together and see if we can get you feeling good. So in this first one, now remember how I talked about communication-wise when we did substitution, I wanted you to have your two equations side by side each other so that we could work down in two columns. For elimination, you want your two equations on top of each other, and you want to be able to read x's on top of x's, y on top of y's, numbers on top of numbers, okay? So these equations are as simplified as we can make them, and they are lined up. So those guys are done already for me. The next step is to make one of them the same magnitude. Well, actually, that one's already done as well. I see a plus 3y and a minus 3y here, so I'm actually ready to eliminate. Those are the same magnitude already, okay? So now what I ask myself is, how do I eliminate? Would I want to add those together, or would I want to subtract them from each other? Well, because one of them is positive and one of them is negative, if I add 3 and negative 3 together, that's what gives me 0. You're always about what's giving you 0, okay? So for these guys, I'm gonna add, and that means I add the whole column. all three columns there. So 4x plus x is 5x. This gives me nothing. -6 plus -4 is -10. So now I have 5x equals -10, and I'm ready to solve for x. I just have to divide both sides by 5, and that gives me x equals -2. Okay? So once I know one of them, I go back to one of the original, it doesn't matter which one, plug in what I know, and solve for what I don't. So I knew that x is -2. So now I have 4 times -2 is -8. I want to add 8 to both sides, and then I want to divide both sides by 3. And so y is 2 over 3. Now remember, just like with graphing and just like with substitution, your solution is the coordinate point. Okay, so make sure you answer as a coordinate point. The solution is bracket -2 comma 2 over 3. Okay? All right, they're going to get a little harder as we go, but it's the same kind of concept. So first of all, everything's as simple as I can make it. Everything's lined up on top of each other. And actually, again, on this guy, I'm ready to eliminate. Okay, I have y and I have y, so I don't need to do any multiplication. These are just ready to go. Now, how would they go? Would I add these together or would I subtract them from each other? I would actually subtract this time because the signs are the same. Okay, so here I go to subtract. 2 minus 1 would give me x, and -7 minus -4. Just be careful with your double negatives there. Always remember, that's why I always put like this big addition or subtraction sign there, because then I can always remember, okay, it's -7, subtract -4. That's going to give me -3, because when I subtract a negative, it's like adding. Okay, so now that I know that x is -3, I'm going to plug that into one of my original equations and solve for the y that I don't know yet. So I get -6 plus y equals -7, add 6 to both sides, and y is -1. Okay, so now my solution is -3 comma -1. Okay, awesome. Okay, next guy. Now this one's a little bit trickier. I am still as simplified as possible, and I do have everything lined up, but I'm not actually ready to eliminate. Okay, so I need to think, okay, what's the easiest thing for me to do? I could try to eliminate x's. If I wanted to eliminate x's, what I would be looking at is making them both say 10x, because I could multiply the top guy by 2, and I could multiply the bottom guy by 5. Or I could eliminate y's just by multiplying the top guy by 3, and then I don't have to do anything to the bottom guy. Okay, and one doesn't really matter over the other. You may want to think about, you know, whichever one is the path of least resistance, whichever one makes the most sense to you, and whichever one involves the least amount of steps. The more steps you take to do a question, potentially, the more chance there's a little error somewhere in your steps, right? So I chose to eliminate y. And so what I'm doing, remember, I'm very big about the communication of this, okay? What I've done is I put an arrow on both equations, and I'm going to communicate to my reader what I'm about to do. So the top guy is going to get multiplied by 3. The bottom guy I'm not going to do anything to. I'll just rewrite him in a second. When you go and do the top guy by 3, you have to remember that it's every term that has to get multiplied by 3. So 5x is going to become 15x, y is going to become 3y, and then this 9, don't forget about that 9, he'll become 27. Okay, and then the bottom guy I didn't do anything to, so I just rewrote him, and now I'm going to work with the fact that I've got a 3y and a 3y here. Do I want to add the columns together right now, or do I want to subtract them? Which will eliminate the y for me? And the answer to that is subtraction. So 15x minus 2x will give me 13x, and 27 minus 1 will give me 26. Now I divide both sides by 13, and that gives me x equals 2. Once I know that x equals 2, I'm going to plug that into one of the original. It doesn't matter which one, but you should always try and go back to the original, just as kind of a check and balance. So I went back to the original. 5 times 2 is 10. I'm going to bring my 10 over, and I get y equals -1. And so my solution is 2 comma -1. Okay? Okay, so now this one looks a little scarier because it has some fractions, but I don't want you to shy away from fractions. Now, in that being said, if you are a person who is going to naturally shy away from fractions, you could just get rid of them, right? You could take this top guy, and you could multiply everything by 2, right? And get x minus 2y equals 6. And take that bottom guy and multiply everything by 6. and that would give you 3x minus 2y equals 36, and then go from there and work on that. That is totally okay if you want to do that. I'm not going to do that with this guy. I am going to work with the fractions only because I look at my x's here and I say, hey, those x's are already the same. So I can just eliminate them right away. I'm ready to go. Do I want to eliminate them? Sorry, do I want to eliminate them through addition or subtraction? They are the same sign, so I want to eliminate them through subtraction. So 1/2 minus 1/2 is gone. -1 minus -1/3. That's the same as saying -1 plus 1/3, and so that would give me -2/3. And then 3 minus 6 gives me -3. Now, if I want to get y all by itself, I will multiply both sides by 3 and divide by 2. Okay, because I have to get rid of the division of 3. That's why I multiply both sides by 3. And that would leave me with the 2y, and I divide both sides by 2. Now, one of those is a negative. It doesn't matter which one you call the negative. So you could say I'm going to multiply both sides by 3 and then divide both sides by -2. Or you could say I'm going to multiply both sides by -3 and divide both sides by 2. Either one, it's the same thing. And either way, you're going to get 9/2 for your y value. Okay, always answer these guys as fractions in simplest form. 9/2 is beautiful. You don't have to write that as a mixed number. Now, I'm going to take y equal 9/2. I'm going to take that knowledge, go back to one of my original, and plug that in. Okay, and so now I'm going to have to add 9/2 to both sides. Remember that 3 is kind of like 6/2 if I wanted a common denominator. So 6/2 plus 9/2 would give me 15/2. And then I want to multiply both sides by 2, and I get x equals 15. Okay, so my solution, still a coordinate point, my solution is bracket 15 comma 9/2. Okay, so I did this one with fractions. If you didn't want to do this with fractions, you could have gotten rid of them at the beginning. You'd still get the same answer, so totally okay. All right. Okay, let's do some word problems together. It costs $25.25 for 4 adults and 3 kids to see a movie, and $26.50 for 3 adults and 5 kids. What is the cost of an adult ticket to the movie? Now, we have to build this whole thing together. So we're gonna start with a legend, and then we're gonna create equations. So what are we talking about? We're talking about the cost of a kid movie and the cost of an adult movie. So I said let X be the adult ticket price, and let Y be the kid ticket price. Now, we know that 4 adults, so that'd be 4X, and 3 kids would be 3Y, cost $25.25. And we know that 3 adults and 5 kids cost $26.50. So here's my system that I'm ready to solve. I either need to get rid, or I want to look at eliminating for X or eliminating for Y. Doesn't really matter on this guy. I'm just going to walk you through both of them for a sec, just so that you get an idea of what's going on here. If I wanted to eliminate X, I would multiply the top by 4 to get 12X, and the top by 3 to get 12X, and the bottom by 4 to get 12X. Okay. If I wanted to get rid of the Y's instead, I would multiply the top by 5 to get 15Y, and I would multiply the bottom by 3 to get 15Y. Okay, doesn't matter what you do, but whatever you do, whatever you choose to multiply by, make sure you're multiplying every term in that equation by that number. Okay, okay. So I chose in my slide to go with the 5 and the 3, so I'm going to end up getting rid of my Y's. So 4 times 5 is 20, 3 times 5 is 15, 25 times 5 is 126.25. Then on the bottom, 3 times 3 is 9, 5 times 3 is 15, and 26.50 times 3 is 79.50. So now I'm set up to eliminate. I want to ask myself, do I eliminate through addition or subtraction for this guy? The 15s are both the same sign, so I want to subtract them, so I get 0y. That's what eliminates y for me. So if I do that, I do that to all of them. So 20 minus 9 is 11x, and 126.25 minus 79.50 will give me 46.75. Divide both sides by 11, and I get x equals 425. Now that I know that x is 425, I'm going to plug that into one of my original equations, substitute x with 425, and solve for y. Now, I didn't do that here because I had actually got to a point where I answered the question, right? And that's a good conversation to have. It says, what is the cost of an adult ticket movie? I never asked you what the cost of the kid ticket movie was, okay? So if the first thing you do actually answers the question, then you're good to go. If this question said, what is the price of a kid ticket movie, then you would have to finish solving the system, and you'd have to figure out, plug in your X and figure out what your Y is, okay? All right, you invest $5,000 for 1 year into 2 investments. Investment A earns 8% interest, and investment B earns 11% interest. If you earned $430 in interest, how much did you invest in each of A and B? Now, we've done questions similar to this before. Actually, I think we've done one with graphing, and we've done one with substitution. So my legend is where I begin. I'm going to say X is the amount I put in investment A, and Y is the amount I put in investment B, okay? So I know that X plus Y has to be 5,000, and then I earn the interest, so I'm gonna go 0.08X plus 0.11Y equals 430, because I get $430 in interest, okay? I'm gonna solve by elimination, so either I wanna multiply this top guy by 0.08 so that my X's are the same, or I wanna take the top guy and multiply by 0.11 so I get my Y's the same. Totally doesn't matter which one you do. I happen to have chosen to eliminate X. If you had already paused me and done this yourself and you chose to eliminate Y, that's totally fine. You will get the same answer, okay? So don't worry about that at all. Okay, so that's gonna give me 0.08X plus 0.08Y equals 400 on the top, and then the same thing on the bottom. I'm ready to eliminate. I'm gonna eliminate through subtraction, because the numbers on my X's are the exact same. So to make them 0, I would subtract them from each other. So when I subtract all the columns, that's going to give me negative 0.03Y equals negative 30. Divide both sides by negative 0.03, and I get Y equals 1,000. Now, even though it's obvious, you have to finish what the question is, because it is asking for both investments. So I'm going to go and plug that back into one of my original equations so I can algebraically determine what X is. X is 4,000, and now I answer the question. Okay, so I'm not answering as a coordinate point here because this was a word problem and I was being asked a question. So the question was, how much did you invest? The answer is there was $4,000 invested in A and $1,000 invested in B. Remember, I talked yesterday, when you're answering these questions, I need to know that you know the right numbers and that you can correct the right numbers to the right context. I need to know that you know the 4,000 is part of investment A, okay? And that the 1,000 is your part in investment B. Okay. The last problem we're going to talk about today is a very kind of famous type of word problem. Jet walks at a rate of 4 kilometers an hour and bikes at a rate of 20 kilometers an hour. If he travels 32 kilometers in 2 hours, how many kilometers did he walk? Okay, this is what your math teachers lovingly refer to as a distance, speed, time question. And we know that it's a distance, speed, time question because when you read it, you're given information about the distance, about the speed, and about the time of 2 different things. Okay, in this example, the 2 different things are jet walking and jet what was he doing? Sorry, biking. Yeah, jet walking and jet biking. Sometimes you'll get this as like a train leaves Chicago at the same time a plane leaves Boston or something like that, okay? But they're always talking about 2 things. And with those 2 things, you'll be given information around the distance, the speed, and the time. So the best way to do this is to set up a cute little distance, speed, time chart where you can start filling in information, okay? So the 2 things I'm talking about is walking and biking. And so I'm going to look at the distance, the speed, and the time for the walking and the biking. Now, when you have a table like this, your goal is to fill 2 of the 3 columns, okay? Once you fill 2 of them, you've got the 3rd one, and I'll show you why in a second. So what do I know? Well, I know the speed of which he walks is 4 kilometers, and I know the speed at which he bikes is 20 kilometers. So I can actually fill those guys in right away. I don't know the distances. I don't know how far he walked, and I don't know how far he biked. So that's why I called those guys X and Y. Now, I said, if you know 2 columns, you've got the 3rd, and this is why distance is speed times time. okay? If I told you you were on the Deerfoot going 100 kilometers an hour for 2 hours, and I asked you how far you would travel, you'd say, hey, I went 200 kilometers. But the reason you can say, hey, I went 200 kilometers is because you took your speed, which is 100 kilometers an hour, and you multiplied it by your time, which was 2 hours, okay? Now, why am I having this conversation? Because I want to represent time. Well, if distance equals speed times time, then time equals distance over speed. I just divide both of those by s, okay? So that means I can represent my time as x over 4 and y over 20, okay? Now, I'm told just a wee bit more information, and that's what allows me to get a system going here. He travels 32 kilometers, okay? You see that? That means x plus y is my total distance. So my total distance is 32. So x plus y equals 32. There's an equation, okay? And my friends, we know he did it for 2 hours. Well, that means the time he walked plus the time he bikes has to equal 2. You got it. Okay, and so my system that I'm gonna work with is x plus y equals 32. That represents the distance, total distance, and x over 4 plus y over 20 equals 2. That represents the total time. This is enough information for me to figure out what x and y is. Now, this is another example where the question actually just says how many kilometers did you walk? So I just need to figure out what x is. Okay, x is my walking distance. Okay, so here I go. What I'm going to do is I'm going to take the bottom guy and multiply him by 4. And the reason I'm doing that is because 1/4 times 4 gives me 1. So that would just give me x, and then I'd be set up to eliminate my x's. Okay. Y over 20 times 4 gives me y over 5. And if you're unsure of that, just remember that this would be like 4 times y divided by 20. So it gives me 4y over 20. And then I just want to reduce that 4 over 20 to 1 over 5. Also, don't forget to multiply the 2. Okay, every term has to get multiplied, so the 2 turns into an 8. I'm now ready to eliminate because I have x's with the same coefficient. So because they're the same sign, they're both positive, I'm going to subtract them. Okay, so I end up with 1 minus 1/5. 1 minus 1/5 is 4/5. And then I've got up top 32 minus 8, and that's where the 24 comes from. So now to get y, I'll multiply by 5 and divide by 4, and that gives me y equals 30. Now that I know that y is 30, I go back to one of my original. Probably I want to use this guy because it's just an easier one to deal with. So x plus 30 equals 32, x equals 2. I have now solved the system. Great. If this is all you gave me, I'd give you probably like 3 out of 4 because it's so important that you conclude by answering the question you were asked in the context of how you were asked. So the question says, how many kilometers did he walk? Well, now I can say Jet walked 2 kilometers. Okay? And that is solving by elimination. Okay? I've posted some homework for you, some things to practice. Do practice them, just like with substitution. Make sure you're neat. Make sure your work can be followed, okay? Don't make your work a treasure hunt. Make sure it's very, very clearly communicated to the reader what you're doing, okay? And as always, if you have any questions, please, please ask, okay? All right, we will see you for the last lesson, which is just really a review of properties of systems, okay? And then that will finish this unit up. So until then, have fun doing math. Take care.